Good morning. Welcome to Oracle TV. My name is Pablo Calapis. I'm the Marketing Director for Systems Marketing in Latin America. And today we're interviewing Rick Heteringhton, the Vice President for Hardware Development in Oracle. So welcome, Rick.
Thank you. Nice
to the show. So I want to start with the first question, Rick. Oracle is investing very hard, in R&D for Spark.
Yes, indeed.
Can you comment on the latest announcements, improvements on Spark?
Certainly. In September at Oracle Open World in San Francisco, we announced the T3 processor, third generation of CMT, Spark CMT, that was preceded by Niagara 1, Niagara 2, and now T3. T3 is based on the Niagara 2 core. There are 16 cores, 8 threads per core, 128 threads in that processor. Externally, it has the same concept that we had developed on Niagara 2, that is the notion of a server on a chip. So integrated memory controllers, integrated I/O, integrated networking functions, all on one piece of silicon. So we express that in systems from 1 socket to 4 sockets, and we call that the Spark T3-1, -2, or -4. What's in our labs currently in post-silicon checkout is T4. So we've redeveloped the core itself. So the core that we're using on T4 and the next 3 or 4 generations of processors was developed in 2006. We started the development of the BT core, and what we're focusing on there is bringing much higher single-thread performance into the CMT line of processors. And not losing sight of the threaded notion that we had on the predecessors on T3 and beyond. So that's the T4. That's in the labs. We hope to be finishing that up by this time next year. It'll be available in systems. So that's what's happening currently. Then, of course, the roadmap that we do show to customers include the M4 series, the M5, T5, and beyond. They'll be based on that core, but expressed a little bit differently in terms of the frequency and the core count.
Okay. So can you explain which will be the difference between, the Spark processors and the x86?
Well, there are similarities and there are differences. I think that if we start at the instruction set architecture level, of course, x86 is based on complex instruction set computer. So this is CISC technology. What does CISC mean? It means that instructions require many more than one single cycle to execute. So they're decoded and they generate micro-ups in the pipeline. So that's essentially it. Spark is based on RISC technology, Resistance Instruction Set computers. So that's essentially the difference. They were developed years ago, and so instructions have been added to both architectures. If we look at where Spark is really targeting and where x86 targets fundamentally, that's where the differences really begin to appear, and differences that are visible, let's say, to the user. So Spark is really server-centric. So it's developed, and much of what we insert and architect in that processor is for servers. And this is servers that can expand from a single socket all the way up to 64 sockets in the future. What we did 8 years ago with the T is highly thread. Understand the nature of the applications that servers run, and they are typically in threading. And so we added an enormous amount of threads to the core itself. So we started with 4, there are 8 threads per core. In future, there may even be as many as 16 threads in a core. Multiple cores, interconnecting that to a memory hierarchy, lots of memory bandwidth, lots of memory capacity on a per socket basis. So that's been the essence of what we've done on Spark. And the x86 side, they tend to be a little bit more commodity focused. So single socket, 2 socket systems, they are increasing in dimensions, so you'll see upwards of 8 socket in the future. They tend to have less memory capacity, competitive bandwidth, and fewer cores. They're catching up in terms of the core count, but the thread count isn't there. They're still modest in terms of the thread count. So they also had started from a point where it was high single thread performance and then multiple cores to gain the throughput. We sacrificed some single thread performance, gained our throughput through threading, but in the future you'll see that we'll radically increase single thread performance, and there'll be a balance at some point. We think at some point that there won't be that much difference between the two processors. You can see x86 perhaps enjoying a little bit more threads, flat on single thread performance, but increasing throughput.
That's good. So going a layer above about software, what applications are recommended for each type of processor?
Well, I think applications that certainly the Oracle stack is fundamentally a perfect fit for Spark, for highly threaded Spark.
Mm-hmm.
The Java middleware, perfect for highly threaded Spark, certainly database. In fact, if you look really back at the history of CMT itself, was designed for database. So we enjoy really good throughput on that. x86 is a little bit more single thread focused. So where response time really matters, that is human felt response time matters, I would recommend an x86 for that. Now in the future, again, we're going to raise our single thread performance through our clock rates and a little bit more smart factor, and so it'll feel a little bit more general purpose as we go forward. So that would be from an application perspective.
Okay. So, what is your opinion on how Oracle software and some servers and storage are supporting the creation of the modern data center that we know about it?
How the Oracle software support?
Yeah. How do you think they support the creation of the modern data center?
Oh, okay. So this is the whole notion of the integrated stack. Mm-hmm. That is the integrated. So as we joined Oracle and are working with our colleagues in the software area, that is the stack as it's defined with the very next layer above hardware would be the virtualization layer, operating systems and applications. We work very closely with all the leads, architects in those organizations to assure that we have a highly integrated solution that is tuned perfectly for the underlying hardware, that is the Spark hardware that is highly threaded multi-core.
So switching gears, talking about green IT, it's in most discussions of IT departments these days. Is there a way you can explain, how Spark processors can address this topic?
Yes. If we go back to the introduction of the T1 processor in 2005, this was an enormous breakthrough in throughput versus power consumption. So we pioneered the whole notion of low power processing. That processor, at the time, we were replacing 6 Intel boxes with one single chip, essentially, and it was around 200 watts, 250 watts in that area for that entire server. And since that time, we've been doubling throughput with each successive generation. And so the doubling of the throughput and multi-socket systems based on CMT technology has increased essentially the power consumed by a single server, but the throughput, that is the performance of those servers, has gone up dramatically, at a much higher rate than the power has gone up. And if you look at where we are today and where we're going in the next couple of years with the performance on a per socket basis, it's equivalent to what you might see in a chassis-based system, and systems that may consume 2 to 5 kilowatts in one single rack system. So I think we're paying very close attention to that. We continue to add features for power management, continue to add features in our software and our firmware to power manage these systems. So what's important is idle time is a really important metric. That is, when servers are in their idle periods, we want to draw as little power as possible. And at peak levels, we want to make sure we're as efficient as possible.
Okay, so you save power, you save energy, you save cooling,
absolutely,
space. Okay,
yes.
Very good. So last question, Rick. Can you explain how Spark, processors family are competing these days against, the market vendors?
Right. Well, with T3, the introduction of T3, T4 coming really fast on the heels of T3. These are highly competitive products. So in multi-socket configurations, we compete head-on with all of our major competitors. As we go forward, we're going to see that the M line and the T line will improve in performance in dramatic ways. So we're on a scale of every 2 years, 2x performance improvement. We measure that in both response time and throughput. So as we get out to 2015, I think we'll see some performance levels that'll really astound our competition.
Okay, great. This is great. Thank you, Rick, and please stay tuned on Oracle TV. Thank you.